I guess we can start the lecture, and also I'll send the poll afterwards. So let's just start. Right, so everybody can see the screen and hear me, right? Hello?
Yes.
Great. So last lecture was called Hello World because that's the typical first lecture in computer science that people like to go for. And typically the second, third lecture that I saw online that other people were teaching was mostly in terms of the mechanics of how code works, some more tools that may be useful. But to me, I think the most important tool that I would want to teach you, which I've also mentioned before in my emails, is sort of equipping you to learn things you may find useful. Because while there's a big branch of coding that everybody needs to learn, there's also, it's a very personal thing where, one may want to use it for analyzing data or for making a website or for a lot of other reasons. And it becomes very important to be able to learn what you need to quickly and then do it. So that's the main focus that I'm going to have throughout the lecture series. And we're going to start working on that from today. So I call this lecture Stack Overflow because that's where you usually go when you're looking for something that you need to do with programming. If you Google anything to do with Python, chances are that 60% of the top results are going to be by this website called Stack Overflow, which is basically a community of programmers who give answers to questions you may have. And it's a free community. It's just people helping out each other because that's just how programmers work. So we'll start with a quick recap of last lecture. And, we first talked about how programming is like building with Lego blocks, and you can make amazing things with Lego blocks, which are themselves very simple. We call these little blocks of code things like objects that we use, and what the order in which we put them together to make something beautiful like the thing on top, like this image here, is called an algorithm. So an algorithm is basically a sequence of actions or a sequence of steps that you take, putting together very simple steps, which allows you to achieve something which may be more important. And that basically is the center of all programming. All that you have to think about is what are the pieces I would need, and what are the orders, what is the order in which I would need to put these together to achieve what I want to achieve. And people who would have tried the assignment would have also realized that we were doing a similar thing. We first read in a file, and we call that a file object, and then we sort of read through it using a for loop, which is another object, and then we sort of stored things into a list, and then we plotted it. So essentially, we're just thinking about what are the steps that are necessary, and then writing small pieces of code that can achieve each of those steps. So code is made of little blocks. And we think of these Lego blocks as like objects, which basically is anything which has a bunch of attributes and a bunch of actions that you can do to it. So for example, for the ones on the right, the Lego blocks on the right, one attribute could be their shape, another attribute could be their color, which define these Lego blocks, and the utility that they can allow you to, that they allow you to sort of build, the object that you can build with them, the things that you could build with them, are basically the actions. So what kind of blocks could be attached together? Those all questions come under actions. For example, we talked about the file object, which comes with this action called read lines, which allows you to read lines. We talked about algorithm being the order in which you put them together in order to achieve some task. And then we talked about using this for plotting the COVID growth in India and in Canada. And that's what the assignment was. And it closely followed what we did in the lecture, barring some very minor variations that I'd added. We'll talk about that later in the class today. But yeah, that's basically what we had. We saw some more things like, numbers and strings. We called these, I don't think I mentioned this in the last class just to reduce the amount of jargon, but numbers and strings are called data types in Python, in programming in general. And if you have numbers, you can do things to them like a plus b, a minus b. So a and b both will be objects, and you can do certain actions to them like adding them, subtracting them. If it's a string, we talked about things like splitting it, which allows you to split a string on a specific character. For example, if your string has a comma in it, and inside the split in the bracket, if you pass a comma, then it splits on a comma. The way to think about this, this is a bit of foreshadowing. We'll talk about functions in today's class, which is probably the most important building block of all code you write. So split is a function here, which takes in the input, and the input that we give is inside the bracket is the character you want to split the string on. We talked about list objects. And some examples that we looked at was, lists of numbers, lists of strings like hi, hello. We also looked at empty lists like the third one here. And finally, we also talked about 1, 2, 3, the characters 1, 2, 3, and making a list of that. We talked a bit in the code about converting these strings of numbers into floats by doing like a float, and the bracket you would pass the number, and that would convert the string into the number. Is this stuff that people remember? If this is unclear, I can quickly go over this. But if you can't recollect this, then just let me know and I'll stop. We also talked about the append function, which allows us to add things to a list. So we could potentially start with an empty list, and then in a for loop, we can keep appending things to the list. We also talked about the file handler object, the open file path thing that we talked about. And this is a file handler object that allows us to read contents from a file. We talked about comments, which were lines that start with a hash. With a hash. Basically, these are lines that you add to your code to help you understand what's going on. Or if someone else was to read your code, they would understand what's going on. You don't really need to. So this is stuff that the computer doesn't read itself. It just basically skips over it. If there are lines in a program that start with a hash, it's just ignored. This is just stuff for you to understand what's going on. We talked about variables. We talked about operators. We didn't use the word, but we use them. So a plus b, a minus b, multiplication, division, all of these are operators. So there's a lot of different operators. The ones I mentioned here are the basic ones. I'm just telling you this terminology because if you ever read anything online, it will show up. And I don't personally think it's a very important topic that needs to be taught separately, but it is important enough that you shouldn't, get lost in the jargon when you see it. So operators are just, add, divide, subtract, multiply, and a bunch of other such things, which take in some input and do some action. Casting, again, we did this. We used float on a string 1, and we can convert that to 1.0. We did this in the code. We didn't call it casting. This is called type casting or casting because it's converting a character, a string, into a float or a digit or a number with a digit with decimals. So this is called typecasting. You don't need to really worry about this. It's just a name that people use. It's just jargon. So probably you could forget about it. If you see it sometime, you would know what it is. We talked about modules, which is essentially a bunch of code that's been written by other people, which can be used by you to do whatever you want to do. So we used NumPy to get the mean of a list of numbers. We also used matplotlib to plot. So we talked about modules. And if you actually go and look at some of the online tutorials of introducing Python, all this stuff that we looked in the first class probably covers about 60% of the introduction to Python. And they go into a lot of detail about each of these things, but I don't really understand why. I think the best way to do it is to just understand it through an example, as we did. So that's the approach I'm going to continue taking in this course in general. And so talking to some of you guys who are working on the assignments or reading the lectures or just feedback from friends, one thing I constantly heard was that the syntax seems nonsensical, it's really hard, it's confusing, and it's unclear why we are doing certain things. So there are these, it's actually pretty common to get lost in the syntax. There are these comics that I found. You sort of get lost in a semicolon, you miss a bracket, and it's just something that will happen. Sadly, there is no way around it apart from just learning to get used to it. This is not to discourage you. It is just to sort of set a certain amount of expectations, in the sense that if you try to learn a new language, it comes with its own set of grammatical rules. You should probably look at that way. And grammatical rules don't really make any sense apart from the fact that they're supposed to be followed. It's the same way for us. So every language comes with its own syntax. For example, C programming or C++ programming would require you to end every sentence with a semicolon. And it happens so often that you forget that semicolon and you spend 2 hours trying to find what's going on. And finally, it is just one semicolon left out in 400 lines. Same thing with Python. You get lost in such things all the time. So it's just, there's honestly no way around it apart from just getting used to it. So if it seems nonsensical, it is a little hard, but you'll get over it. Trust me. Just keep coding. Just keep trying to understand every line. So how do you get better at finding your errors and getting used to syntax and understanding what's going on? If you get lost trying to solve an assignment, you get errors, you don't know what's going on. My one advice to you, or two pieces of advice, which I think help a lot, is try to understand every line that you have written. Oftentimes what happens is that we just want to get one sort of like, chunk done. So for example, we want to plot some numbers in a file. So we just want to read the file and move on. We don't want to worry about too much. So we just copy paste a bunch of lines, write them down, and then hope it works. Often it works. Sometimes it doesn't. When it doesn't, the best thing to do is to try to understand every line that you have written in your program. And the way to do it is very basic. It is just printing out everything. The print function is the best tool that you can get. So identifying your errors in programs is called debugging. And the best way to debug is to print everything that you can. Literally everything can be printed in Python, and you can print out everything. So just do that. And the third most important thing is to understand how the computer is reading your code. So how does the flow move, as they call it, or like what is the order in which the computer is executing your programs. So all of this would make more sense when we go to the next slide. The plan for today basically is to help you with all of these things by explaining to you how a computer reads your code. So we'll look at a demo which goes through your code step by step, telling you how the computer really executes it. Once you understand that, you know the steps that the computer is taking to execute your code. Once you know that, you can actually start to understand, what are the main problems where where the computer may be finding an error. How do you go about checking each of them? How do you go about printing each of them and checking? So that's going to be the first part of the lecture today. The second part is going to be some new tools to communicate with your program. We learned about lists. We learned about files and things like that. Today we'll go beyond that. We'll learn a little more. We learn some very important things called dictionaries. We learn if else. We learn functions. And these are the three most important things that you could probably learn after lists. And we'll cover all of this today. Finally, we will learn how to build something. So in the last lecture, we built something. In this lecture, we're going to learn how do you build something. And the assignment that I will give you at the end of this week is also going to be learning to build something. So you wouldn't be able to find the code for that in the lecture, but you would be able to hopefully learn the process to find that code. And it's going to be a little, it's going to be new, but let's try if we can get past, if we can get this done. So first, let's start with this anatomy of code demo that I'm calling. Essentially, it's just a demo where we're looking at how code is read and executed by a program by a computer. So this is a really nice website which allows you to write a piece of code here, and you can then keep pressing next, and that tells you how Python breaks up and reads your program. So before we start, I think this is a good place to stop and ask any questions that you may have about things we discussed in the previous lecture or in this lecture, and we could go over those before we go into this next piece of sort of demo.
Spandan, will we get into why we do typecasting?
I could give you the answer right now in short. Essentially, you do typecasting because there are certain, so there specifically for Python, typecasting is done so that certain operations become available. What that means is that you can't add two strings the same way, at least, that you can add two numbers. You can't divide two strings. To add, it would still make sense. Maybe I could start with the string hello and then string bye, and then if I add them, it becomes hello bye, just one string. Maybe I could stretch and also talk about subtraction, but division, multiplication doesn't make too much sense. So typecasting is usually done in other languages. It is necessary. You have to let the computer know that if I'm creating contents, for example, you have to specify before contents that this is string, or this is integer, or this is a number with decimals, things like that. So Python doesn't do that because it tries to keep things easy for you, but at the same time that creates confusions. So it's just a way to prevent confusions by letting the computer know that, hey, even though this is a string of 100 zeros, essentially it's a number, it's not a string. Right? That makes sense?
Yep.
Great. Any other questions? Cool. So if there's no questions, we can move forward. What I'm doing here is, I have a print statement, and like we had in our lecture and in the assignment, we had this list called contents, which we had read in from a file. So here for ease, I'm just creating a list. And what I do is very similar. I go over the contents, this list one by one, and I sort of print out everything, and you'll see what's happening here. So let's start with step number one and see what happens. If I press next, the first thing it's done is it's moved this arrow from here to here. What this means is that, so in computers, programs are executed or they are run step by step, one by one after another. In some of the in things like your phones and things like that, they have much more advanced methods to run these things in parallel. But for the most part, most program that we run is written in a sequential order. So it has a start, it has an end. It starts at the top and ends when it reaches the last line. That's always how it's read like English in some sense. So it first looks at one line, and the moment the line breaks, it's a new statement, it's a new line. So that's why you count the number of lines that you have in a program, and it runs it line by line. So first it runs this line, it ignores line number 2 and 3 because there's nothing there. So it jumps from 1 to 4. So you could potentially get rid of these two lines here and it wouldn't make much of a difference, but it would make the program much more difficult to read. So a lot of this white space here in general is just left so that it's easy for us to read and write and not get confused while writing the code. Other languages like C++ actually take this to a much more bigger extreme, but Python still has some notion of breaks and line breaks and things like that. So it executes the first line, which says print this string that I'm giving you. So the output is it prints out this line. Once it's done this, it moves to the next line and it's standing at contents. When we press contents, it creates an object. So this object gets created in the memory of the computer, where it's created this list and it's storing these values. What is this? This is a list which has how many elements? 3 elements, which start at 0 because Python starts at 0. So this one has 3 elements. Each of these elements themselves is a string, which is these numbers separated by commas, which is very much like what we've seen so far in a lot of our files. Now, the task that we're going to do is going to be exactly the same. We want to read all the cell 0 numbers. So 100, 200, and 300. So imagine if this was like a file where this could be the first line, this could be the second line, and this will be the third line. If you did f.read lines on this file, you will basically be creating something like this. So we do the same. We create an empty array. And when we do this, you'll see it actually creates an empty list. So it lets you know that in memory, in the computer, it's set aside some space in the memory, and it's called that empty list. And once you add some contents in it, it will start populating, it will start adding to this empty list, and it will become a non-empty list then. But for now, it's an empty list. Now we enter the for loop. And I think this is where the reason why I wanted to show you this flow is to explain how a for loop basically works. Because this is entirely different from everything else that happens that you've been seeing so far, which is this gets run, it comes down, this gets run, it's comes down. When you run this for, first it sets I, and then it prints the value of I. So when it says for I in range len contents, this basically means it's going to go from 0 to the length of contents minus 1. So 0, 1, 2. So it goes here. And when I ask it to run, to print out the value of I, it prints it out here. I is currently 0. So when I say line I contents equals 0, what's going to happen is that this is going to get stored in a new object. This isn't being printed here, but line I a variable has been created, which stores the value of contents 0 in this case, because I is 0. And then you could, when I do this, the empty list now gets populated because it stored the value here. Does this make sense to everybody? Or is this a lot of moving parts?
So why doesn't this display the variable as well as the objects?
That's because ideally this page displays a bunch of other things here, which it calls frames. I wanted to not go into that right now to prevent confusion,
Right.
but that prints out a lot of other things that are going on under the hood. So apart from this, there was a column on the left, there was a column on the right, and that would just necessarily complicate things right now. So I didn't want to add that much detail.
Got it.
But it's happening in the hood, under the hood. I've actually deleted those things from the page right now.
Okay.
Right. So what happened here is that we read in the contents 0, which is this. Then we split it. And then, as you would have seen, if you tried the assignment, this would not work because we have split it on nothing. If I ask it to split on this instead, now it will work. And this will show up now actually. So might as well just, this stuff is what I was trying to avoid. So like, oh, sorry. Let me just delete this. Okay. So now because I'm splitting it on a comma, you would see that it splits these values. So the things that we pass inside the brackets are basically telling what to split on. Before we hadn't specified anything, and by default it just splits on byte spaces. So if there was a space here and here, it would have done the job. But because we need to specifically split it on a comma, we need to specify that. So what this does when you start is that it sets I equals 0, it prints out I, it stores the contents stores contents 0 in line I, then it splits and it creates this cells in line I list again, which has 3 elements, which are the 3 elements that were present here. Now I can store just this particular value in this variable cell 0 in line I, and that gets stored. And I append that to this empty list, which shows up here. And the thing that happened is that instead of going down here, the line moved back up. So if I go one step back, the red arrow is going to move one step up. So the green arrow shows you last line that was executed, that was this, and then it went back up. That is why we call it a loop, because it basically loops over this bunch of code over and over again till this particular condition or thing is met. So now it's going to do the same for I set equals 1. It prints I is currently 1. It sets the contents of this here. You'll see this will get overwritten. It got overwritten by 24020. And now this one will have a value appended to it. Now becomes 100, 200. And then it repeats the same thing for I equals 2. But now when I press it enter again, it's going to move out of the loop. There you go. It goes back up. It checks if this is done, if it's actually looped through all of the values, and then it comes out of the loop. So this is how the computer is running your code. Just to sort of explain once again, it starts from the top, starts running stuff one by one, starts creating objects, starts storing variables, empty lists, things like that. Once it enters into the loop, it starts running things for a particular value of I, runs through everything, goes back up, checks if the condition is met, the condition is not met. Oh, sorry, I mean, the condition is still working. I is still in the range of 0 to 2 and keeps going. Now, when it comes back up, the value is beyond what it needed to be. It's now set at 3. So it's going to exit out instead of going inside. And now if I print all cells, it just prints out the values that I'd stored in this object, which we've been seeing that keeps getting appended over the loop. So this is just to explain you what is going on as to how the computer reads your code. And typically, if you're trying to understand, someone else's code or trying to write a piece of code which is complicated and it's unclear how to do it, this is how you're going to do it. This is how you try to understand what's going on behind, like sort of under the hood in some sense. Was this helpful? Did this make sense? If there's any questions about this, I can take them right now.
Spandan, what's the difference between pseudocode and what we just saw?
So pseudocode is just a bunch of, it's just logic independent of syntax. So when I say syntax, that means writing it in a certain way, which would help the computer understand all the details of how to run your code. Pseudocode would just be like read file, split line, store first cell. That is what you write for yourself when you're building the algorithm. When you're writing out the algorithm in a way that someone can understand it, first of all, it's independent of all language. So pseudocode is the same if you code it in C, in C++, Java, in Python, for the most part. There may be tiny variations depending upon what a particular language allows you to do. But that's the idea behind pseudocode. It's stuff that you do before you start writing code. It's stuff when you're deciding what is the order in which I'm going to solve this task. That's what we call pseudocode.
Thank you.
Great. So that brings us to our sort of the second most important thing that we're going to see after lists, and it's called dictionaries. And so let us just consider a database of books, products, people, anything. Typically, every item in a database is defined by an ID. And this ID could just be something like an employee name, a patient ID, an ISBN, QR code, whatever. And you often want to store a particular value for this ID. Imagine it could just be employee details, and there the ID would be the employee name or an employee, some kind of ID that is given to an employee. And values could be everything about the employee, like their salary, their age, maybe the designation they work at in the company, and things like that. For a library, it'll just be where is it stored in the library. But essentially, storing an ID and a value pair is very commonplace. It's something that we do all over, like very often in a lot of things. A lot of information is stored like that. So dictionaries are built-in objects that allow you to store ID value pairs or key value pairs, as you call in Python. Key is just ID for an element in a dictionary. So lists are for storing list of values, which is very intuitive. Dictionaries are storing pairs of values where you can look up any pair by its ID. That's the sort of the essential definition and the use case for a dictionary. There's also other reasons why they're made and computational advantages that come with them. But for the most part, for now, this is all that you need to know about dictionaries. Why they're so important will also be covered probably in a later lecture once we start writing pieces of code that are actually very slow if you don't write them well. Right now, we are not at the stage where we worry about how fast our code is. We just want to make it work for now. So we won't worry about anything else beyond just the fact that it's for storing key value pairs. And so I'm writing the syntax for lists and for dictionaries side by side here, just because I think you have some experience with lists now. So to create an empty list, you would just use this. For an empty dictionary, you would use curly brackets. And the reason why these brackets are different are exactly so that you can tell the computer if it's an empty list or an empty dictionary. So in other languages, which are much more verbose, you would actually have to define things, give them, let the computer know if it's a dictionary or a list. Python makes it slightly more easy, faster to write by picking certain brackets for certain use cases. So a list is defined, if you create an empty list, it's defined by these square brackets. An empty dictionary is defined by these curly brackets. Now, you could append to a list like this by just using the dot append and adding a value. Dictionaries take in values like this. I realize this is probably not the best design because they use curly brackets here now. But what are we going to do? I mean, we can't really do much about it. It's just something that we have to live with. That's how the people who designed Python chose to write it. So this is a bit of memorization, but the important thing is to let the computer know, or let the Python interpreter know that you're storing a value in a dictionary. You need to provide both a key and a value pair. So employee 1 here is the key and 5,000 is the value. This could just be something like employee salaries, for example. And if I was to print the list on the left, it will show this list with the number 1 in it. And if I was to print the dictionary, it would show up like this. So I realize this is new syntax and it gets a little confusing, but the important thing to understand is you can create empty lists, you can create empty dictionaries, you can append to empty lists, you can add a key value pair to an empty dictionary, and you could potentially just print them out to see what's going on with them. Does this make sense?
Swandan, please.
Okay. After print for both list as well as the dictionary, what is that thing like? We are again back to the square and the curly brackets. So how do we know that at the end we are supposed to come back to this?
What does that mean? As in, like, what brackets to use?
Yes.
That's honestly just memorization. You just get used to it
Okay.
over some time. Yeah.
Until now, like when we write the print command, after that we don't write anything like for the code in
Oh,
after the next one.
okay.
But after
I'm so-
here,
I'm sorry, that's a bug. The the bracket at the end of the print statement on the dictionary end should not be a square bracket. That's my error. Sorry, that should be a normal parenthesis bracket, just like the print, just like you have on the left, the same way. So for example, this, I'm sorry, the stuff is covered under some stuff here, but essentially this should be a curly bracket. This is my error that I made. I'm sorry about this.
and after that we are supposed to like write this employee
Oh,
one.
this automatically gets printed. This is the output if you ask it to print. So you
Okay.
stored stuff in this dictionary, right? And when you ask it to print, this is what it prints. That's the idea here.
Okay. Okay.
Does it make sense?
Yeah.
Great. So this is honestly just, the brackets are, it seems very, difficult at the beginning because it's all like a bunch of different brackets going on. It doesn't make any sense why you want to use curly or square or normal parentheses, but this is just stuff that you sort of get used to over a period of time. The important thing to remember is the key value pair part of dictionaries. And another important thing is that the values that we gave in this dictionary, we just stored 5,000. We could actually store a list here. So we could have a list like, this one, 10, 20, 30, 40, and we could store this as the value in the key value pair. So if you have, I could create this, dictionary called COVID dict, and then I can add a value to it where the key is India and the value is this particular list. And I can add another value called Canada where the key is Canada and the value is another list. In fact, Python allows you to put pretty much anything, any object as a value in a key value pair. It also allows you a lot of things in the keys themselves, but typically you want to go for something simple like a string or a number or something for keys. But for values, you can pretty much store anything. So you can make dictionaries of dictionaries where, the value itself is a dictionary. And that's actually a very important thing that you use in Python. You make dictionaries of dictionaries all the time. You can make, this one is a dictionary of lists. The previous one was a dictionary of numbers. Essentially, you could store a lot of different kinds of objects as values for dictionaries. And the reason why I go into this is because we'll actually see this in the later half of the lecture. So yeah. And an important thing is, how do you access information inside dictionaries? So for lists, you can access it with these square brackets. You can again access it using square brackets for a dictionary, but you need to mention the key. In a list, you mention the position. So if it's a list of 3 numbers, you can get the first number by entering list 1, 0, list 1, 1, and list 1, 2. So in a list, it's all about position. In a dictionary, it's all about the key value pair. So you need to specify the key for which you want the value. Does that make sense?
Yes.
Great. So another thing is, you could loop over a dictionary just as you loop over a list. For a list, you would loop over by saying for I in range, len, whatever. For a dictionary, you could loop over by saying for key in covid.keys. So covid.keys is a list, and it's very much like saying, for I in this list or for key in this list. It's very similar, but it's slightly different in terms of syntax. Was there a question there? Okay. So what's going on here is that COVID is a dictionary that we created on the previous page, and covid.keys returns all the keys that are stored inside this dictionary. And then you can loop over them using the for loop, just as we did in the previous case. So this is essentially trying to say that how do you walk through a list and how do you walk through a dictionary are slightly different in terms of, the specific syntax that you write, but essentially you could loop over both of them. Right. So now that we understand, what a dictionary is, one of the very important things that you use all the time is called if else. And I'm assuming people who've seen Excel might have seen this before. The idea is very simple. You want to do two things, and if one condition is met, you do one thing. If not, then you do the other thing. So if a condition is true, do this. If otherwise, which is called else in Python, do that, the other thing. You could also extend this to more than one things by having if, elif, which is short for else if, and then finally else. So you would see programs where you would have if condition 1, then execute this bunch of code. Elif, second condition is true, then execute this second bunch of code. Otherwise, do this third bunch of code. So this is very intuitive, I feel, if else statements, and we use it all the time, ourselves. It's just very much how we think. So I think this makes a lot of sense. Is this stuff that is intuitive, or is anybody having trouble understanding this? Because I could go into more details otherwise.
Yeah, makes sense.
Cool. So some examples of conditions is, I could set this variable to 1000 and I can say print a greater than 2000. Now this seems weird because what I've done is I've printed out a condition. Why do I do this? Is because you will see conditions like if a greater than 2000 or a greater than 2000 all everywhere in your code. And the idea is you can actually print out a condition like this, and if it's true, it will print out true. If it's false, it's going to print out false. As I said, you could print out everything in Python, but essentially you could also use this as something like this. If a is greater than 1000, do something. If it's less than 2000, then do something else. But what we're seeing here is that we first set a variable to the 1000, and this particular part that we're focusing on right now is called a condition. And every condition is either true or false. You can't be both simultaneously. And you could print those out. But just as printing, you can also use it in your code like this. You can set a equals 1000. You can say if a is less than 2000, just print less than 2000. And this is what you get. So when you run this program, the output actually is less than 2000 because the number is less than 2000. So I think if else is very intuitive, but the idea is if else often gets used along with a lot of other things, which allows you to do more interesting things. So here's an example of, a lot of things that we've seen so far. There's lists, there's a for loop, there's if else, and there's a dictionary. So the problem we're trying to solve here is that assume we're given a dictionary called employee salaries, which stores all the employee salaries, where the key is the employee name and the value is the salary. And what we want to do is we want to get the list of all employees that earn more than $4,000 a month, for example. So what we do is we make these two empty lists, more than 4,000, less than 4,000. Then what we do is we loop over our dictionary using for name in employee salaries keys. We read the dictionary by entering the key. So employee salaries square bracket name returns the salary for the employee with the key name. That gets stored in salary. And then we can just use an if else statement to store it either in the more than 4,000 or the less than 4,000 case. So at the end of this, we would have two lists with names of employees. More than 4,000 would be all employees who earn more than $4,000 a month, and less than 4,000 would be all employees who earn less than $4,000 a month. So as you can see very quickly, in very simple things that we want to do, you have to use a combinations of objects like lists, dictionaries, if else statements, for loops. So it's very important to get used to the syntax with these things because you use them over and over again. And this is sort of the building block of pretty much everything you would want to do with Python. Is this example clear? Not the specific syntax, but like the general idea. Is that clear to everybody?
Spandan, one thing. So this for name in employee salary key allows us to loop over the entire key list inside a
Yes,
dictionary.
exactly.
Can we also choose to only go to specific section of key values in the dictionary instead of looping over the entire?
Well, you have to specify which keys, and then it's basically the same. Yes, you could, instead of doing employee salaries or keys, you could just have a smaller list of, keys that you do want to go over, and you could loop over them as well. You can loop over any list basically, right? And employee salaries.keys just returns a list of all keys. If you made a smaller list and you want to loop over them, Python doesn't really care. It's okay with both. Does that make sense?
Yeah, it does. Thank you.
Great. So this brings us to the second most important thing that we'll do today, which is functions. And I think functions are basically the most important thing you could learn in programming in general. And the idea is just that they're chunks of reusable code that you want to keep using over and over again. And they're taken, so a lot like functions in mathematics as well. I'm not sure if that's helpful though to everybody, but essentially functions take in inputs and they return outputs. Most often, I say most often because you could have a function which does not take an input. You could also have a function which does not have an output, but that doesn't happen very often. For the most part, you have an input and an output. So it looks like this. You put in something, get out something. Usually what you get out is more useful than what you put in. And that's why you do, all the work inside functions. So we're going to look at some code of how you can use functions, and this may look a little intimidating. So I'll try to step through it. But let's walk over this code step by step. So the first sentence says import numpy as np. And the first question is, what is numpy here? And as we know, that's a module. The second question is, what are these two lines in red? This is sort of just like a revision. It's a comment because it starts with a hashtag. So these lines that start with hashtag are completely ignored by Python. They're just for us to help us code and understand our code. So we start our first function and we start with this line def. So def is, it's a string that lets your computer know, that lets Python know that what comes after this is a function. So in Python, whenever you want to create a function, you will first start with def. So you'll say def function1 name, def function2 name, then def function3 name. Whenever you start, you first mention def. Then you name the function. So squared is the name of the function. Then you specify the input that it will take, which goes inside the square, inside this brackets. And inside, which you can see with the indentation. So as you can see, after def, there's nothing below it. The lines are indented. So the function continues till the time the lines are indented inside. That is how Python knows when the function starts and when the function ends. It starts at the def function and it ends once the indentation goes back. So at the print, because it is in line with def, Python knows this function is ended. It ended above this line. So you take in an input, you take x, you square it, you store it in squared, and then you return squared. Return defines the output. So this is sort of like the anatomy of a function. You start with the def. You may or may not specify any input. Here we specify an input x. You could specify more than one input. Maybe it's a function that we look at more input functions below. And then return allows you to return the output. So if I was to run print squared 8, what this does is that it takes the input 8, puts it inside squared, which would return 64, and then that goes into print and that prints out 64. I could also specify, make a slightly more complicated function just using Pythagoras theorem here. So I call it Pythagoras, where I specify side 1 and side 2 of the triangle, and it returns the hypotenuse. So all that it's doing here is that it takes in side 1, it takes in side 2. It actually calls the function that we saw above, squared. So functions can call other functions, and that's usually how you write code. So Pythagoras calls squared on both the sides, adds them, stores that into a new variable. np.square is again, it's a function that comes from numpy, from the module, that is used to get the under root, and then that returns the under root of the square. So if you pass 6 and 8 to it, if you pass 6 and 8 to Pythagoras and ask that to print, it prints out 10. This sort of explains how functions call each other, how functions work, what the input is, what the output is, and how you may want to use them in a real life application. So this is pretty much what you would see all over very often. And it's very important to understand how functions work and to write a few functions, because if you don't write functions, your code will typically get very long and very ugly very fast. So you'll have to keep rewriting the same thing over and over again. So if you've done the assignment last week, you realize that you basically redid the code for India and for Canada. You did the exact same thing twice, and you didn't need to do that. You could have just written a chunk of code and then reused that. Does this make sense? Yeah.
One question, Chandan.
Yeah.
Is there another function here in the third line where there's a square root which is being taken?
Yes. So np.square is also a function.
Yes, and so this would have to be defined beforehand, I suppose.
It's defined in import numpy.np. That's what. So we discussed this briefly in the first class. We talked about modules, where if you load a module that can be used, that has its own functions that someone else has written, so you don't need to write it, because square root is something that's used very often by people. It's just made available for everybody to use.
Okay, so when we were trying to make this function do the Pythagoras theorem, we did not need to define that it needs to take the square root of the two sides?
We did define it. We defined it using, and we basically called numpy inside our code. So hype squared takes in two sides. So Pythagoras takes in two sides, calls squared on each of them and adds them. And that's the first line. And we store that value into hype squared, the variable.
Right.
And then we call numpy from the first line. And we use that to perform a square root and store that in another variable and then return that. So if you remember in Pythagoras theorem, C equals under root a square plus b square.
Yes.
And that's what we're doing here.
Yes.
Make sense?
Yes. Thank you.
Yeah, sure. Great.
Spandan?
Yeah.
Do we need to define the type when we are creating a function? For example,
Not in
do
Python.
we need to define? Okay.
Yeah.
So
in
we
other
can then
languages,
pass anything?
Yeah. You could potentially pass in, so we've talked about how you could create your own objects, and we talked about this very briefly, right? But you can pass in pretty much anything in Python. So this language like Java would not allow you to do this. It would stop you, to raise errors, because it's a language that is, in general, is much more robust, and it's not meant for quick, easy coding. It's meant for robust, error-preventing coding. But in the case of Python, it's supposed to be easy. It's supposed to be fast. So it allows you to do a lot of things, which just seems like intuitive. You want to write a function? Sure, just pass in any input. Doesn't matter if it's a string. Doesn't matter if it's a number. It could also be something else. You can pass functions as inputs to functions. So it gets very complicated very fast. But for now, this is the basic that you need to know.
Understood. Thank you.
Great. So we saw this, and I just wanted to quickly explain what's going on under the hood here. Is that you pass 8. That's the input that goes into the function squared that we defined. That gives the output 64. That goes as an input into the print function. And that's what we output when, the print function always outputs onto a screen. So it just prints out the number 64 onto your screen. And this whole step, sort of the series of steps of calling functions, in a computer science lingo, it would be called function call stack. And you very often see functions being chained together, being called calling one function from another. In just this piece of code that we saw, we already saw so many functions being called within just one very simple function, like finding the hypotenuse. We saw squared, we saw np, we saw square root, all these things going on, and then that calls on print. So there's a lot of functions calling on other functions, and the way we describe this process in computer science is called the function call stack. Why is it called stack is something that we don't want to go into right now, but essentially it's called a stack. Let's just call it this. You can just think of it as a stack of books, and they're sort of executed one by one by the computer. Great. So let me see how much time we have. We have about, take the liberty of taking about 15 minutes, I think. And let's quickly code something in these 15 minutes based on what we saw. Okay. So what I'm going to do is I'm going to quickly go over the assignment that we had, because I think that sort of covers a lot of the important things that we talked, once the internet helps out. But essentially, this is just comments that are supposed to guide us through what we're trying to do. What we saw in the script is that we have these modules that we're importing, and we imported numpy, and then we also imported this thing called matplotlib as plt. And these are two modules. The reason I wanted to show you how to code this through is because it just to build a more better coding practice kind of situation. Typically, you want to add all your imports at the top of your code. That's just a coding practice that people like to follow. And it's something that's followed pretty much by most people, so I thought I'd let you know. Then you would write your functions. In this case, what we're trying to do is we're trying to read the values for India and COVID, and India and Canada COVID numbers, and they're already stored inside this location, inside these files. But I don't want to repeat the same thing for both of these countries. So what I instead do is I define this function called def get country data, and that takes as input the country name. So and then what I could do is I could potentially just call this using get country data, and I could pass in India. And to repeat this for Canada, all I need to do is write one more line. And that prevents, copying and reusing code. Another thing it does is that it allows you to break things into chunks that are easily understandable. And then once you're done with one chunk, it works. You don't need to worry about it again. And if someone else reads your code, it is very easy to see what are the chunks or the algorithm by reading through the name of the functions, because the name of the functions sort of tend to explain what the function is doing. So the first thing that I need to do is I need to define the file path. And as we saw, if you have, in this case, the path, the name of the file changes depending upon the country, which is very convenient for us because we just learned what the if statement is. So what I can say is if country name is equal to India, I can set path, which is called this file path, and I can copy this file path by clicking here, saying this. Else, or we could also use elif, Canada. I can say file path equals, and copy the path of Canada, and store this. And this is a very common way that we use else. So if I don't enter India or Canada, this piece of code is not trying to handle other countries. You could just say print does not work for other countries apart from India and Canada, right? And we can potentially just stop here and already run and see what happens. So I could just say, I could choose to not return anything. As I said, we don't need to return something. This works. This is a perfectly fine function. It's not going to create an error. And if I just say get country data and I enter in the brackets US, it says does not work for the countries because it went in, when I ran this function, what I passed here gets stored as country name. Just as when I was doing squared and I was passing in the number 8, X got set equal to 8 in that piece of code. Here, when you pass in US, country name gets set to US. So it comes in, it says, is country name equal to India? And the answer is no. Is country name equal to Canada? And the answer is no. So it just comes down here and it executes this line of code. It says, does not work for other countries. Now what we can do is that we can also print the file path. And now if I was to pass in India here, it should print out the file path for the India COVID dataset. Now we repeat what we've been doing so far, which is, I can just say all confirmed equals this, all, I think the second column was recovered equals this, all deaths equals this. And then I can loop over the file by saying for I in range len contents, but first I need to read contents. So that will be read as with open file path. So earlier we were actually writing down the file path, but now we can use what we've stored above in a variable and we can do this, the stuff that we've seen before. You can say line I equals contents I, and then let's just print line I and see what we get here. We see that we get an error. And that's because we missed out this colon. So see, syntax is a problem that keeps popping up pretty much for everybody, including me all the time. So what we've done here is we've printed the contents of the India COVID file. And we see that there's this extra line break here, which is because we're not doing the rstrip thing. So what we can do is line 1 parts, maybe. And we can do line 1 dot line I dot rstrip dot split, and you want to split on a space. And we can append these values. So the first cell is in line I parts 0, 1, and 2. And these are the values for confirmed, recovered, and deaths. I'm doing nothing new here. This is exactly what we've seen before. And what we do now is that we have to return these values, and we can return, just as there can be many inputs, there can be many outputs. In this case, we obviously want to return all these three. So what we can do is we can do this, this, and this. Now, the exact same piece of code will allow us to read the confirmed, recovered, and deaths, the 3 columns of data for a country very easily. Now, if you're outputting 3 values, and if you call the function, you would need to obviously read it into 3 values. So when I do this, when this function gets run for India, it runs all of this code for country name set to India, and it returns these 3 lists. So A, B, and C will basically end up storing lists. If there's no bugs here, which seems there's none, interesting, I can just print A. And this should be the list of all confirmed cases. Great. And as we've seen before, we don't need the first column. So what I can do here, I can start from 1. So this is, if this seems fast, it's just stuff that we did in the first class. So if you go and read, the lecture 1, this should seem like stuff that you've seen before. And I've stored this for India. But we also saw another way to store stuff, which is we just create a dictionary. And now what I can do is I can store also, instead of passing 3 values, I could potentially also just pass 1 value. And what that would do is that A itself will become a list with these 3 things. This is slightly tricky because you could choose to either pass it like this, in which case A will be all confirmed, B will be all recovered, C will be all deaths, or I could choose to just do this, and then A of 0 will be all confirmed, A of 1 will be all recovered, and A of 2 will be all deaths. Sorry. So you have the choice to do it either ways, depending upon what you may want to do, the way you want to store your data. But now what this allows you to do is to store this thing into a dictionary. I could just say COVID data, and because I'm storing into a dictionary, I specify the key, and I can get the value by just saying this. So this is going to store a list, this thing here. And I can just repeat the same thing for Canada by doing Canada. And then I could plot these things. But the most important thing is, say if I plot this stuff, I have this stuff, now I want to plot this, and I see plt.plot COVID data India. This is going to return this thing. And I can't plot all of these lists together. I need to get one of them. So what I can do is I can either store it separately and then read it, or I can just do this. Because as we saw, all confirmed, all recovered, all deaths get stored into this single variable. And then I can access each of them using 0, 1, 2. That's what I'm doing here. So there's a lot of variables moving around, a lot of things being stored on a lot of things. But essentially what this allows you to do is to make your code slightly clearer and slightly neater to understand what's going on. This was meant to be fast because I wanted to sort of, get you to get used to a lot of things moving around. But the most important thing I want to go over very quickly today is I want to add a title to this graph. What do? I say add title to matplotlib plot. And this is, intimidating. There's a lot of things going on. So what do? You see, come here. There's a lot going on here. It seems a little scary. Try to understand what's going on. This does not seem very useful. You go back out and you find another link. You find this link and you find this bunch of code. You find here something which says title. So what you do is you just copy this code and you try to understand what's going on here. You see, all right, I understand this line, I understand this line, I understand this line. This is just creating 2 lists. Okay, that makes sense. I understand these lines as well. This is plotting stuff. Okay, and these are new lines. So what does this do? This is something interesting. This allows you to see what adding a title, adding Y label, X label to existing graphs is. And the way to do it that we just, so typically I would not know a lot of things about how to add things to plots, happens all the time. And the way I would do this is I would actually go onto Google and I would search something like adding titles, or let's just say add how to read image Python. Now let's see this. And I mean it. Happens all the time where I would not know how to do certain things with reading images. And I would try to say, all right, this looks like a module. This looks like I read something with the module. And this looks like show, like plt.show, which is what we've been doing. So I would try to make sense of what's going on here. I would come to this another link or Stack Overflow, and I would talk about how do you read images. There's another way to read an image from PIL, import image, that looks like a module. I use this module to do something, I store it into a variable, and that does something. So the reason why I wanted to walk you through this very simple introduction to using all of these things that we've seen before, lists, if else statements, reading files, dictionaries, moving between different objects. And I realized this was very fast. It was meant to be. I want you to go back and quickly, maybe you could look at this part of the lecture once again to understand what happened. And then what I want you to do is to actually go and try to add titles to plots that you did before. So I want you to go and Google and see how you can add a title to this. It would be something like, plt.title. There could be something like plt.x label. There could be something like plt.y label. And these are all things that I'm not going to give you the complete code for, because assuming you've done the first part of the first lecture and the first assignment, this should take you not more than 20 to 25 minutes to understand what's the right way to add these labels and X labels and titles to these things. And I think that it's very important to build this capability of Googling and adding new things, because that's what the second assignment is also going to be based on. We'll extend what we have, but I won't give you the code. You would extend your first assignment by reading things online, by Googling, just like the way we did right now. You would Google, you would read one of these Stack Overflow pages, you would copy 1 or 2 lines, see what it does, try to understand the structure of this code as module, variable, using a module, file path, things like that. And you would extend on what you have right now. So I overshot a little bit, I'm sorry about that. But essentially, that's what I wanted to give you today. I wanted to quickly go over all the things that we did the last time, show it to you in the context of important stuff, introduce you to some more things like dictionaries and functions that show up very often, if else statements. And I wanted to give you a complete application of how these things are used together, which is what we saw in solving assignment 1. So that also allows you to get the answers for the assignment that we saw before. And yeah, that's where we'll stop. The assignment that we'll give you will build on what we did in the first assignment by requiring you to Google and try out a bit of code and learning how to learn to code using Google, essentially. If there's any questions, I can take them.
And then could you please connect the how to use list and dictionaries in function?
So in a function, you could run any piece of code, right? For example, here's a function that's just a bunch of code inside. That could be a list that we append to, like we did in the previous lecture. That could be a dictionary. If you want, you could create a dictionary here. Well, I could potentially just say country dict, and I can just say country name here. And I could set this equals to this. And I could return this potentially. So inside a function, you can write any piece of code. Whatever you want to write works fine. You could use it to run a function and then store the output in a dictionary. You could use the dictionary inside the function. A dictionary is just an object like a list. And you can store anything inside a list or inside a dictionary.
Thank you.
Okay, any other questions? Cool. So we'll stop here for this week. And I realized that, both the first week and the second week are pretty heavy. And there was a lot of work to be done. And maybe it also might be slightly beyond what you had bargained for in the beginning. But I suggest that if you can keep up with it for 6 weeks, it is a very intense course schedule that I'm designing for the reason that I want you to be able to do stuff yourself at the end of these 6 weeks. It might be taking a little more work than you expected, but I feel that it's going to help you out in the long run. So go back, compare the code from this lecture to the previous lecture, and see how that helps. Okay, I'll see you all next week.
Thank you.
Thank you.